Okay, hi everybody. So we're back here with the next part of our SX1050 Restore series, and I've just completed doing the tone control board. I'm going to go over with you a couple things before I put it back together. As you can see, I did a full recap, and kind of was a little picky about how I did this. Any of these little bright orange capacitors, these are all directly coupling signal capacitors, so these are actually in the signal path, and they are very high quality themselves, and typically you can leave them in and they'll perform really well. But as you saw on the last video in the series, you know, some of these caps have dried out and are leaky and are not performing properly. These ones, again, they don't tend to do that, but better safe than sorry. And so I've replaced them with really good quality film capacitors, which actually you just can't beat those for signal path over the electrolytics. I also replaced the tantalum capacitors, several of those, also with film, and the any of the electrolytics. These are all power supply filtration. They're all high quality, 125 degree, low ripple, good high-end Nichicon capacitors. And then any of the higher values, like 10 microfarads and so forth, I replaced with the Nichicon fine gold capacitors. The ones that are particularly important is this one here and this one here, because these are the ones directly at the input. And let's take a look here. If you look right in here, this is the tone control amplifier that we're working on, and if we zoom right in here on the inputs, here's your signal coming in from the last stage, from your volume control stage, and it goes right through this 10 microfarad capacitor. So this is a very critical component here, so as are these 4.7s and, you know, all those little ones. You can see they're everywhere in there. So we did the film capacitor and the fine gold capacitors for those, so they will do well. Another thing I did that may make some of you guys cringe, especially a lot of guys who are really into electronics and kind of know how things work, I did make a slight change to the tone control section. Now, one of the reasons I don't mind doing this is because there is a tone defeat. If I want to play the music accurately, I'm going to disable the tone control section anyways by turning the tone defeat switch on. But when I do want tone control, these amps, to me at least, it's just my opinion, are just a little bit thin on the bass, on the low end. And the Sansuis and Marantzes always seem to have a tiny little bit warmer sound. These are a little bit brassier kind of sound. Not much, but a little bit. So in an attempt to clear that up a little bit, what I did was, in the 50 hertz, which is the low bass control, which is right here and right here, you can see these are 0.056 or 56 nanofarad capacitors. And what I did was I swapped them out right here with some 68 nanofarad. So it's not a big jump, but just a little bit, and hopefully that will open that up. Now, I did not do the math. I did not sit down and try to figure out the RC time constants and all that to see the, you know, what, and the voltage and everything, to try to figure out how that's going to affect the tone. But just by increasing that one notch, it's just going to give us a little bit of deeper bass on that 50 hertz right there. So it's not going to be center pointed on 50 hertz either. It'll probably be a little bit lower than that now, which is what I want. Again, we'll try it out and see. We always know what to do to replace it, you know, to go back to original if it doesn't turn out how we like it. But I've done this in the past, and it has always, to me, sounded much better, much warmer, just giving it a little bit of improvement, you know. So for, you know, 50 cents worth of parts, you make the amp have a kind of a different personality a little bit. And again, that's just kind of a thing I like to do. Again, my ears aren't what they used to be. I don't hear as well as some people do. So to me, I kind of like that sound. Alright, so went through and I cleaned all the potentiometers and checked them all out, made sure everything was good. We flip this around and go to the foil side, and you can see that's all nice and clean. Can't even tell we were on there soldering almost. And I'll probably go through and just put a little dab of silver solder on the at least on these signals right here where the the signal wires come in. Don't necessarily have to do that, but just as a preventative thing, I will probably go through and touch that up a little bit, and go in and clean the little switches back in behind here on this board, which is just a little bit tedious, but I'll go in and do it just in case for good measure. They seem to be working just fine. And from there, we'll put it together and we're ready for a test. Now, the next part in the series after we do a test on this will be a complete realignment of the tuner, especially the FM. It's got some issues, so we want to go through and take care of that as well. So anyhow, there we are, and let's get everything together and we'll be back. Okay everybody, I'm back, and it's been about a week or two here. Things have been really crazy here at work and at home and with the kids and all these things, so really haven't had a lot of time on the bench. But I'm getting back a little bit this evening, and I kind of want to update you here where we are. Got all the rest of the system recapped, and as you can see, redid the caps on the tuner, redid the caps on the protection board, checked out the relay here. It's all perfectly clean, all good, and redid all the caps in here, cleaned all the controls, cleaned the faceplate, put it all back together. Everything's looking good. So the final part of this video, which is probably going to make this a pretty long video, and I'm going handheld here so I can get a little more into this shot here, is the tuner. And this is what we're going to work on right now. Now, I know a lot of you have been waiting for me to do something on FM tuner alignment, so I'm going to take this opportunity to do this on this one. So we're going to, I'll try to do my best for you guys to go through a complete alignment. And I also want to try to explain a little bit, at least from what I know, about FM stereo and FM in general. And again, there are people out there that are way more knowledgeable than I'll ever be on this. But I'll share with you what I know, with the disclaimer that I'm not an authority on it. So, don't jump on me too hard there on the comments, because I'm warning you up front. I know enough to get by, and that's about it. But I'm going to try to kind of get you primed on how this all works. The AM portion, I'm sure you're all pretty aware of how it works. You've seen me do this a million times. So really, I'm going to kind of skip over the AM alignment of this receiver, and we're going to go more into the FM alignment and talk a little bit about how FM multiplex and demultiplexing works. Okay? And again, I'm not going to give the most technical explanation. I'm sure there's some people with a bunch of letters after their name, what kind of degrees they have and everything, that probably will do a better job than me, but I'll do my best for you. So let me get some materials together, and I will try to demonstrate in a very simple manner how this all works. Alright, so here's how we're going to start this out. I have a couple of printouts, and we're not going to spend too much time looking at printouts. I'll try to flash some images up on the screen as I'm talking, so I'll edit those in when I edit the video. And but let's first of all start by looking at our schematic here of what we have, how this particular tuner is put together. So if you look here, let's see. Right here we have a block diagram, and it's hard to see a little bit. I'm trying to look through the camera and everything, of the entire tuner assembly. And you can see the FM section is up here. This is the part we're concerned with at first, okay? So you look, you basically have your input of your antenna, you have your RF amplifier, you have your local oscillator down here. So basically this works, you know, similar to an AM radio. So you have your RF tuner coming in, you have your tuning capacitor, your coils, and you tune in your station, okay? Now an FM broadcast in the United States, it's a little different in some of the other countries, but in the United States, FM broadcast is somewhere between 88 and 108 megahertz, okay? So you basically have a 20 megahertz span, okay, for the FM broadcast band. The first channel will start at 88.1 megahertz, and the last channel will end at 107.9 megahertz, and they are spaced 200 kilohertz apart. So in other words, each channel would be 88.1, 88.3, 88.5, 88.7, 88.9, all the way up to 107.9. And the reason that they're spaced that way will become a little more clear as we talk a little bit about how an FM station is put together. So basically, if you count those all out, there's a theoretical possibility of 99 channels you could have at any one time in one geographical area without interfering with one another. So what this does is this allows you to tune your channel from your 88 to 108 megahertz. It gets amplified through this little MOSFET, goes through and your mixer and your local oscillator, and they beat together just like in an AM radio, and they heterodyne, and you get your 10.7 megahertz. So you know how your AM radios are 455 kilohertz, intermediate frequency, or IF. These are working at 10.7 megahertz IF. So basically, you take your channel, you tune it in, and you convert it into an intermediate frequency of 10.7 megahertz. That 10.7 then, in this particular tuner, the SX1050, goes through a series of filter amplifiers. So you have these three ceramic filters, and they narrow the bandwidth to filter out any noise. They're 10.7 megahertz filters, and you can see there's a little amplifier chip here, okay? And if you recall on the video I did on the SX750, one of these filters was actually faulty. It was bad, and we had to replace it, and of course all the sensitivity came back. It's the first time I've really ever seen one of these filters be bad. I'm sure other people have had that happen, but for me personally, that's the first one of these. These are usually pretty reliable. And if you remember, it's just a tiny little thing. You can go back to the SX750 video to see it. So anyways, we're cleaning it up with these three filters, and then we go into our detection. Now when you see this tapped coil and you see these two diodes, okay, and this two capacitors, and then your output here off this little inductor, this is a very, very textbook case, and I'll zoom in here for you, of what we call a ratio detector. Okay, this is a ratio detector. There's different types of FM demodulators or detectors. The ratio detector is one of the most common for these analog tuners. You also have a quadrature detector. Then you can get into your more modern ones, which use phase lock loop. We're not going to get into all that on this, but just so you know that after your RF goes into here, we now peel off the audio, and the audio is, think of it as a package. It's not we'll get into this here in a little bit more, but anyhow, when I start putting up the images on the screen. So basically, your audio comes out of here. Part of it goes down to your FM detector and goes in, and this is where you're going to get your stereo out of. And then the other part is just for mono FM. Okay, and then that all goes down into your amplifier. So what we're going to do is I am going to do a couple of diagrams of how a FM station is put together, is packaged, how a multiplex FM stereo channel or broadcast is packaged into a RF package, and then how we unpackage it and split it into a left and right stereo channel. Okay, so bear with me here, and we'll get some videos up here, or some images, and I'll try to explain this. And this is going to be a little difficult for me because I'm going to explain this, but the images aren't going to be up until I edit the video. So this is a new thing for me. I'm going to try this, and you guys can let me know how it goes for you. All right, be right back. Okay. The first thing I want to talk about when we're talking about FM and then FM stereo is we first need to kind of identify what FM is versus AM. FM is not very well understood by a lot of amateur electronics people, to the point where, you know, in the United States anyways, FM has other meanings than just frequency modulation. You know, in my industry, in the medical electronics industry, like X-ray and so forth, you ask somebody, you know, how does this work? How does that work? And it's very complicated science or electronics. You know, people say, well, it's FM. You know, and of course that has dual meaning. FM is very difficult for some people to understand, you know, frequency modulation, but it also stands for some type of magic, and you can fill in the blank for what guys call it. But anyhow, all joking aside, FM is not that difficult if you kind of understand what's going on. So first of all, amplitude modulation is just that. You have a carrier frequency of a set frequency, you know, 570 kilohertz, let's say, in the AM broadcast band. And by making the amplitude of that carrier bigger and smaller, we can actually remove the carrier from that, which is what we're doing when we're doing AM detection, and the modulation of that signal will be the only thing left over, which is your audio. Okay. Well, FM is very similar, except instead of modulating the amplitude or the up and down of that carrier frequency, we're modulating the frequency of that carrier frequency. In other words, we're starting at what we call a center frequency, let's say 100 megahertz, and then we're varying that frequency, bigger and smaller frequency, or higher and lower frequency, off of that center frequency. And then we're taking out all of the amplitude modulation, because AM is very susceptible to noise, as we know. FM is not. So that's an advantage. I'm sure most of you know about frequency modulation, but there's a few kind of rules that we have to know to understand why FM radio works the way that it does. Okay, so the first rule is, what you're going to find out is, we've always heard, you know, any of us audio people, especially people who are into stereos and high-end audio, we always hear about the, you know, the audible frequency spectrum for humans, at least for us, is from about 20 hertz, okay, up to 20 kilohertz or 20,000 hertz. So we always have been taught that, you know, a good audio system can reproduce the entire audio spectrum from 20 to 20 kilohertz perfectly. Well, that's not so with FM. What you're going to find out is, in a typical, and I'm saying typical FM receiver, you're limited from about 50 hertz. Okay, it can technically go down to 20, but Normally they're filtered out at about 50 hertz up to about 15 kilohertz. Now, why would that be? Well, when you look at the way that we divvy up our frequency spectrum, it makes a little more sense why they did that, okay? First of all, if your stations are centered or are spaced 200 kilohertz apart from one another, okay, that means your center frequency, okay, of a station has to be, you know, right on one channel, and then it can only be 100 kilohertz on either direction. Don't know if I'm explaining that right or not. I'm almost confusing myself with it. But the bottom line is you only have, let's say, theoretically, 200 kilohertz to work with, okay, of bandwidth. And one thing we want to do is we want to be able to be backwards compatible, okay? When FM first came out, it was mono, just like AM. And you only had one channel of audio. The problem is, to come up with a new system to broadcast stereo would normally require that we come up with a whole new system that our old receiver would not be compatible with. So that means you would have to have two different stations, you know, one for a mono broadcast and one for the new stereo. But what people did was pretty ingenious, and what they did was they utilized that wide bandwidth of 200 kilohertz, and they divvied it up. And what they said was, from 0 to right up to, but not including 19 kilohertz, we use that for the mono or one channel broadcast. So that's left and right channels together, okay? So if you just have a normal FM radio, like just a radio that you would put on your table, just a portable AM or AM FM portable mono radio, it will only look at the first 19 or 18 kilohertz of that station. And it's a general agreement that you only use the first 15 kilohertz of that 19 kilohertz, okay? The reason we do that is because of the filtering. To make a filter have enough Q or enough sharpness where it can clip off a frequency that abruptly is very expensive and very difficult to design. So what they do is, to make sure you don't bleed up into that 19 kilohertz range, they start tapering or filtering at 15 kilohertz. So theoretically, 15 kilohertz is the highest frequency you're going to hear in a perfect FM broadcast, okay? It's just the way it is, okay? So you are not going to get full fidelity of 20 to 20 kilohertz on an FM broadcast. You're going to get about 50 to 15 kilohertz. That's how the filters are set up, okay? It's just a general agreement. Now, there's nothing in the law that says you cannot have, let's say, an 18 kilohertz broadcast. The problem is, you're going to find out in a minute here that we need that 19 kilohertz for something else. And to clip off an 18 kilohertz that it does a complete roll-off in a 1 kilohertz range, it's very difficult and very expensive. There are some receivers that have done that, and there are actually a few commercial FM broadcast stations that broadcast in that range. Some classical music stations are out there that do broadcast in a very high fidelity 18 kilohertz frequency range. But general rule of thumb, most FM stations and most receivers will only receive up to 15 kilohertz. I know I'm sounding like a broken record, but you need to get that in your mind before you can understand the next part. Now, above that, and remember, we're doing a process called multiplexing. And what multiplexing is we're basically combining several frequencies or several waveforms together, we're overlapping them on top of one another and making one complex waveform that we can later on separate back into its individual pieces. Okay, so back to our model. And again, I'm explaining this, and I hope I'll be putting up the images here properly as I'm doing this. So from 0 to just under 19 kilohertz, or 0 to 15, let's say, kilohertz, is your mono station. That's your bandwidth for your mono broadcast, okay? Any frequencies in that range will be broadcast in that range. Now, above that, we are going to package another signal that we're going to call our FM multiplex signal. And it contains the information that we will need to separate left channel from right channel and have two channels. So your other channel data is going to be in that upper range, okay? And the bottom line is this package in a normal multiplex, okay, and there's other things too that we have, RDS and things. I'm not going to talk about those right now. The multiplex left and right channel plus your mono is all going to be in a 53 kilohertz package. In other words, there's 53 kilohertz of bandwidth. It's divvied up in 0 to 15 kilohertz for your mono. Then above that, we have a trigger signal that we call the pilot signal. The pilot signal is a monotone. It is a 19 kilohertz tone, okay? So remember, it's being filtered out, so you're not going to hear that. Even if you have that good of hearing, which I don't, you would not hear the 19 kilohertz tone in a stereo station because it is being filtered out. At 15 kilohertz, we're starting to filter out everything above that for our mono signal, and we're filtering everything below the 19 kilohertz for the upper part, okay? So that 19 kilohertz bandwidth is being isolated by filters, and we call that the pilot signal. Now, that pilot signal, there is a tuned circuit in your radio called your pilot, and whenever your FM receiver resonates, you know, that receiver sees a 19 kilohertz sine wave, it locks onto it, and it brings in, I'm going to show you here, there we go, it brings in a relay. See this little relay? And this relay is called your pilot relay. And what that's going to do is that's going to actually bring the FM stereo multiplexing circuit into play. In other words, if there's no 19 kilohertz tone, it just works as an FM tuner, mono. If it sees a 19 kilohertz pilot tone, it's going to kick in all the rest of the circuitry that it's going to need to deal with the next part of that package, which is from 23 kilohertz up to 53 kilohertz, okay? And that 23 to 53 is where your information for your left and right channel are going to be, okay? And the type of signal that's called is, it's called a double sideband suppressed carrier signal. Now that's a big fancy word, okay? Any of you ham radio people that work with ham radio would understand what a sideband is, and a single sideband. A single sideband is one band, you know, next to the carrier, you know, to the side, upper side or lower side. But double sideband is both sidebands together, okay? And suppressed carrier. So basically what we're doing is they're equal opposites, and when they beat against one another, they cancel each other out. But if we take another signal and either add or subtract it to those, we can extract the sidebands individually and get our left and right channels individually. So hopefully you can see this by some of the diagrams, okay? So to put this together, the first thing we're going to do is you're going to take your left and your right, original left and right stations, okay? And I'm going to stop here and start another video here so it doesn't get too long. Okay, I'm back. So we're going to take our left and our right. We are going to put them into a multiplexing circuit, and basically left and right are going to get summed with your 19 kilohertz oscillator, okay? And the 19 kilohertz oscillator, you're going to have basically a phase lock that's going to lock onto that and double it into a 38 kilohertz oscillator. That is going to get added to your left minus right signal. So you're going to take the left and right, you're going to subtract them apart, then you're going to take the left and right and add them together, and you're going to make two separate signals, a sum signal and a difference signal. The difference signal is going to be added together with that 38 kilohertz signal to make a double sideband suppressed carrier signal centered at 38 kilohertz. So why 38 kilohertz? Well, 19 kilohertz above, 19 kilohertz below. When you add your filtering to that, you got your 15 kilohertz maximum frequency. So basically it'll have the same frequency response as your mono FM, but it'll just be stereo. Then those all get added together with your pilot tone, and you get an output that we call our FM multiplexed output. Now, to a normal FM radio, it won't see anything above that 19 kilohertz. It'll only see everything below the 19 kilohertz, the 50 hertz to 15 kilohertz we were talking about, and it'll tune it in just fine. All the rest of that stuff that we talked about is all filtered out, and it doesn't even know it's there. However, if you notice, that 19 kilohertz is directly linked into your multiplex signal. It's riding on your carrier as a separate individual tone. When your tuner sees that, that pilot relay is going to kick, or the pilot circuit's going to kick in, and it is going to go to what's called a demultiplexing circuit on the other end on your tuner. And what you're going to do is you're going to undo all the stuff you just did. So first of all, you're going to take your 19 kilohertz, and that's going to be kind of like your phasing. Okay, so that's going to be like your phase control. Everything's going to time itself off of that 19 kilohertz tone that the radio station is broadcasting. And that 19 kilohertz is going to lock in and become doubled into your 38 kilohertz. It's then going to be added and subtracted to get your subtract your sideband information and get your left and right signals, and then they're going to be individually sent into the right and left channels. Okay, and this is all done through filtering and through what we like beat frequencies. Okay, so I'm sure you're all scratching your head right now and saying, how does this work, and what did you just say, and I don't understand a thing you said, and you're telling this wrong anyways, and there's a better way of, and I'm sure you're all thinking a lot of different thoughts. So let's try to visualize this. Okay, let's get all the videos and things off the screen right now. Let's go back to our tuner, and here's what I've got. Okay, so I have my Pioneer SX1050 that we want to work on and adjust. And before we go into an alignment, we're going to do a little simple demonstration of how to trigger the stereo light on your stereo. And really the stereo light is tied into that little relay that's called your pilot circuit. Okay, so the pilot circuit is tied into your stereo indicator light. So that being said, let's look at the scenario that I have. I have my tuner And in the antenna jack, as you can see, I have a wire. And it's going to the output of my HP 8657A signal generator. And if you look at my signal generator, okay, can you all see that? If you look at this, I have 100 megahertz, which is right kind of in the middle of your, of our FM broadcast band. So I'm making myself a little radio station at 100 megahertz. I'm running it at negative 50 dBm. That's not real important for right now. It's just a strong enough signal for the radio to tune to. And if you notice, I'm doing something different. I am set up for FM modulation, but I am using an externally modulated source. So in other words, I'm putting a tone into my external input jack for external modulation, and I'm FM modulating it, okay? If that makes any sense to you. Now, very simply, I have a wire here, you can see, and it goes and gets plugged into a very basic audio generator, okay? And right now my audio generator is set at about 1900 kilohertz. So if I turn on my radio right now, if I turn on the receiver, I'm going to bring you way down here, and hopefully this camera will tune in. This is a new camera, so I'm still checking to see. Here we go. Okay, and can you all see the stereo indicator down here, right? And I have it tuned in to a station to 100 megahertz, and if I turn this up, can you hear that? So that's about a 1.9 kilohertz carrier tone, or audio tone on my 100 megahertz carrier. Very simple. It's just a simple modulated signal, right? Now, I have 1900 hertz on there because if you look at my meter, and I'm going to bring this handheld for a minute, if you look at my signal generator, you can see it's times 100 times 1000. If I go from times 100 to times 1000, it'll move that from 1900 hertz to 19 kilohertz. So watch. Now you can't hear it because it's 19 kilohertz. But take a look. What happened? FM stereo. Let me go back to 1900. I'm just going to click it. You ready? Click. Light goes out. Click. Light comes on. So simply by putting a 19 kilohertz audio tone on my FM carrier, I am triggering that FM multiplexer circuit, and I'm faking it into thinking there's a stereo station there, even though there isn't. Okay? So what has happened now is that left and right signal is now being rediverted through our demultiplexing circuit. And of course it's mono, so you're still going to hear, you're not going to hear anything because there's only the 19 kilohertz and it's being filtered out. So all you're going to get is static. Just static. That's it. Now, if I had more signal above that 19 kilohertz, from between 23 and 53 kilohertz, you would actually hear that audio, and it would be split up between the upper and lower sidebands and between the left and right channels. Okay? Simple as that. So what we're going to do when we align this receiver, okay, is the first thing you do is you turn off the 19 kilohertz pilot and you inject a basic mono FM signal into the receiver. And that's the part where we're going to go in and we're going to adjust our IF circuit. Okay, so let's go up to here. this is where we're going to adjust our IF, you know, with our local oscillator. We're going to tune all that, and we're going to make sure that these filters are working. All the way out to here, we're going to be able to test all of this, okay, with just a basic FM carrier and a basic modulation. Okay, and it'll go clear through our ratio detector and all the way out to our audio. However, in order to do the next part, which is going to be your FM pilot and your multiplex, you're going to need to generate some other signals. And that's where we're going to have to come in and use that SG1050 we were messing with on another video. And you can see it has a setting called multiplex signal. Alright? And you can see I can put a 400 hertz audio tone on the left and a 400 on the right, and basically turn on my 19 kilohertz pilot, and I can actually individually generate a left signal and a right signal. Okay, and that's what the SG1050 is good for. Okay, you have to have a multiplex generator in order to do this. Okay. The SG1050 is one that can do that. There are other signal generators out there. RCA makes an old tube type one that I have. I think it's called the WR52, I think. And it's a multiplex stereo generator. Works really well. But really all you're going to do is we're going to, at that point in time, we can either, there's one of two ways to do it. And I'll tell you how the two ways to do it, and then I'll tell you how Pioneer wants you to do it. Way number one is we're going to take that multiplex signal out of the SG1050, and we're going to plug it right up here into the input of our external modulator, and we're going to modulate this FM with a multiplex signal. And we're actually going to simulate a full-blown stereo broadcast station and tune it with our tuner. Now that's one way to do it. That is not the way Pioneer has us do it. Pioneer has you take that multiplex signal directly, and they have you inject it on one of these test points here. You see all these test points? There's actually an FM multiplex input, and you would direct inject that in there and bypass all of the other stuff. Remember, in the first part of our alignment, we aligned the FM IF section, the local oscillator, the tuner, the dial indicator. We do all that first. So there's no need to mess with that part of the circuit. Now you're going to bypass that, you're going to first inject 19 kilohertz into the pilot circuit, and we're going to adjust it till the FM stereo light comes on, which we're not going to need to do that. As you saw, it already works. Then you're going to move your multiplex signal over to the input of the multiplex section, and in this instance Pioneer does it with integrated circuits, and you can see there's a couple different chips that work together to do all this, okay, for your demultiplexing. Alright, and that's these two chips down here, and they're going to actually there's a couple of coils in here you adjust. It's very simple once you get the signals in the right way, and you're going to adjust those. Now there are other methods, visual methods, where you can put an oscilloscope, and I think Pioneer gets into that too, and you actually can peak the coils so you're perfectly centered. You know, your left, your right, your carrier, everything, your pilot, they're all centered using either an oscilloscope or a you could probably even use a spectrum analyzer, but mostly you use a scope. So we'll go over that, and hopefully that'll make a little sense, but I really want you to get a feel for how a multiplex signal is packaged together before you worry about how to align this. If you don't understand what it's supposed to do, how on earth can you understand how you're supposed to align this and what it's supposed to look like? You know, you can blindly follow the directions in the manual, but as you'll see, they're not really, they don't explain a whole lot. They assume that you know all this stuff about FM and about stereo, And so as a result, they skip over a lot. They just tell you the details that you need. Hook your meter here and do this. And they assume that you already know what this is. So, hope that helps. Next thing, let's get some test equipment connected up and let's start going through the alignment. And remember, part one of the alignment is just FM mono, you know, the front end. Doing our IF and our local oscillator, our dial indicator, all that. Okay? So we'll be back. Okay, so we have the test equipment set up for our first alignment process, which is basically we're just going to set the oscillator so that we can our dial accuracy is accurate at the low end. So if you look at the instructions for this tuner, at least, what they're trying to tell us to do is you want to hook up the measuring equipment, and we're going to set the signal generator. Notice it's an FM signal generator. Now, let's talk a little bit about test equipment here, because I know I get a lot of comments and a lot of questions about signal generators, and especially after I did the one on the little, this Tenma up here, if you remember when I did that. And basically, when you're doing AM, okay, so you're going to do an old shortwave receiver or an AM radio or something, you know, CB radio. Those are all amplitude modulated. We talked about that a minute ago. And really, a basic RF signal generator with basic modulation will do just fine. If you're going to get into FM, you are going to need a little bit more advanced equipment than that. And basically what you're going to need is, first of all, you're going to need test equipment that is capable of frequency modulation, okay, FM. So if you look on my HP, my 8657, it has a carrier frequency adjustment and it has modulation adjustment. So it's split up like into two sections, okay? And so the carrier is where we just set your sine wave, your basic RF frequency that you want to transmit at, or you want to simulate, and you set the output amplitude, and you have different options of how you want to set that amplitude. Okay, so I have an option of measuring relative to dBm, which M stands for milliwatt. Okay, so 0 dBm would be 1 milliwatt, and then negative would be a logarithmic value of that, negative, you know, smaller than 1 milliwatt, and a positive would be greater than 1 milliwatt. Okay, we're not going to get into dBs today, how that all works. And we can also have the output measured in volts, millivolts, microvolts, EMF, which would be the actual representation. So bottom line is we can set our output very accurately. That's important with a signal generator, and what you're going to find out is it's not a big deal on AM, old ham radios, you know, shortwave receivers and things, but when you start getting into things like this, you want, especially if you're going to adjust a signal meter like an S meter, even on the AM, you want to have an accurate representation of how much signal you're putting into the receiver so that you can make that meter represent that signal, if that makes sense to you. Now, this type of equipment is a little higher end. It's kind of a laboratory grade where you would use for calibration. These little, like we did the video on this guy up here, it has an adjustable variable attenuation, but it doesn't have an accurate measurement. So if you're going to use something like that, you're most likely going to need to have some means of being able to measure it, okay? And there are several different ways we can do that. We can still use this, but you may want to use, like I ordered this online. Let me show you real quick. I know I'm kind of taking up a lot of time here, but I get a lot of questions. This is something you can order on eBay, about 20 bucks or so, 15, 20 bucks. It has a little screen on it. It's USB powered, so You know, if I just plug this into a little USB jack, turn it on. You see here, I'm not even, there you go. And you can see it turns on. And it has a little input here. Okay. And this is basically just a little, it measures the frequency accurately, and it'll actually measure the output. See there? dBm, how many, the amplitude peak to peak. And you would need something like this to be able to accurately adjust the output of a signal generator like that. You buy a little higher end one, and it basically has that capability built in. So I hope that answers some of your questions and makes a little more sense. Okay. Again, this one can do FM modulation. So if we zoom in here a little bit on the buttons, you can see where it says, and everything's moving on me here, FM and AM. I'm set up right now for internal FM modulation, and I'm just putting a 400 hertz audio tone, FM modulated, on my signal carrier, and my carrier is set at 90 megahertz, which 90 megahertz, if you recall, is a FM broadcast band station, okay, or frequency. What you're looking at down here on the oscilloscope, here we go, is left and right channel coming out of the tape record jacks, okay? So that's all they're doing. And if I turn the volume up, you can hear that. That's that 400 hertz. This represents your 400 hertz. And if you look right here on the scope, it's saying 400 hertz. Okay? So right now, what they're telling you to do, and this is just kind of from my experience, they're telling you to set up 90 megahertz, and they want a 400 hertz tone, okay? And it really doesn't matter what the, some signal generators have a 1 kilohertz tone. It doesn't matter. All that matters is that there's an audio sound that you're carrying on that, and you're just connecting it to the antenna jack, okay? And that's really what they're saying up here, figure 29. They're just showing you how to connect it to the antenna jack, which is right here. It's kind of hard to see, but there's the antenna jack, there's your signal generator, and we're just setting up a very basic FM signal, okay? Now, they talk about 100 dB. Now, I believe what they're talking about is 100 dB microvolt. They just didn't put the, you know, the what they're measuring, and this doesn't really do dB microvolt. My device, I always try to keep everything in dBm, okay, which is dB milliwatt. And what I have found, and this is just from experience, I'm not an authority, I'm not telling you what Pioneer wants, but they just want a strong enough signal that you can get a clear signal through the tuner without a whole bunch of static. And that cutoff point is right around, if you notice, about negative 50 dBm. Okay, now these receivers, when they're tuned in properly and aligned, you should be able to go clear down to negative 100 or even a little further dBm and still be able to faintly receive that signal, because these tuners are pretty good quality. They can do that. So anyways, I have a 90 megahertz, and probably getting you all dizzy moving the camera around so much. And I've basically tuned the dial to 90 megahertz, okay? And the first step, and you can hear I'm tuned in, we're right here on, this is the main front end of the tuner, okay? So under this shield is your main tuning capacitor, and you can see the little dial that goes to your dial cord, okay? This is hooked to the tuning knob, and these are going to be all of your adjustments for the front end. So the first thing they want us to adjust, if you look here, is T4, okay? And T4 is this oscillator coil right here. So we're going to set our main oscillator right now, okay? And what this is going to do is down at 90 megahertz, which is down towards the lower part of the dial, they want you to set this for dial accuracy. So what I do is I put my, well, I'm going to have to go mobile again here. I put my tuning dial directly at 90 megahertz, and a lot of times these old tuners will be a little bit out of alignment. So what will happen is you won't hear anything. So it'll sound kind of like this, perhaps. Okay? So you'll hear noise such as that. And basically what we're going to do is we would adjust this oscillator coil, and we will look at our oscilloscope and adjust it at 90 with the dial set right on 90 till we get a nice clean pure sine wave of 400 hertz. That means that that tuner is the dial pointer is at 90 and the actual tuner is tuning right at 90 megahertz. Does that make sense? Okay. The next thing you're going to do, okay, and this is our next step, is now you want to adjust the meter, okay, your tuning meter, so that it's centered, okay? So sometimes this can drift a little bit, and what that's going to do, T6, is this coil right down here. See it? This tall one. And this is going to adjust the centering of your tuning meter, which is right here. And you notice it's right on. I didn't have to touch it. It was perfect. But let's say it was a little bit off, okay? If it was off, then I would adjust this until that tuning meter was right straight up and down in the middle. Okay? So far, so good. Next step. And this is going to be a similar process for any tuner. It doesn't matter if it's Pioneer, Marantz, Kenwood, you know, all of them pretty much, Sansui, they're all similar because they have similar tuners from this era, okay? So the next step we're going to do after T6 is now they want you to change the signal generator, and they want to put a small signal, okay? And they want you to adjust T1, T2, and T3 for maximum indication on the signal meter. Okay, so you're going to use the signal meter to peak those three coils, and those happen to be your you know, like for your local oscillator and so forth. And again, with this dB, you basically want to turn this up and drop your amplitude till you get a little bit of static. So you hear that static? So I just have a little bit of static in there, and if you notice, okay, my meter is kind of low right now, and it's like that on purpose, okay? And what we're going to do, and I don't like to use the meter, I like to use the static on my scope. I think it's more accurate, and I listen to it by ear to peak it. So what's going to happen is we're going to go back over to here, and they want you to adjust, let's see here, they want you to adjust TC1, 2, and 3. So TC1 is over here, it's this one. TC2 is this one, you skip one and it goes here. And TC3 is right here. So they're 1, 2, and 3, and we're going to adjust those three adjustments for maximum peak. Now I have a feeling this one's pretty close, but we're going to find out. That first adjustment that I did, where we adjusted this coil, I did that one off camera. It was off by quite a bit. It was off by probably about almost a half a megahertz, okay, or so. So to bring the dial in, So that brought it right in. So we're going to do these now. Now again, sometimes these screws can be a little hard to turn. They're just little ceramic pads that you're adjusting with metal screws. You want to use a non-conductive, okay, tweaker. This one is just made out of plastic, and you can also get, these ones are ceramic and they're actually a little bit harder and a little bit better to use. So either one will work. And all you're going to do is we're going to get on this right here. You can see I'm on it. And then we're going to go over and we're going to look at our scope. I'm going to turn up the volume a little bit, and then I'm going to just rock that adjuster, you know, back and forth, clockwise and counterclockwise, till I get the maximum clarity and signal. So here we go. Right about there is going to be it, okay? And if you look at the signal meter, it's also about as high as it's going to go, okay? Now we're still getting static because I put a weak signal in here on purpose. I'm at negative 70 dBm, okay? Now we're going to go to the next one, okay, and I'll show you that. We're going to go to our next pad, which is right here. This is TC2, and we're going to do the same thing. And these are really not out. They're pretty close as I move them. Okay, that one was out. That one was out. See how the static dropped way down? And now let me look at my signal meter. My signal meter came up 1 S unit. Okay? So that one was out. All right? So this tuner was a little bit deaf, and we said that up front. It didn't sound right. All right, now we're going to go to number 3, which is right here, and we're going to adjust it and see what we get. Okay, here we go. That was off. See there? See how that's almost gone? Okay, and we've reduced that static quite a bit. So 2 of the 3 adjustments were out, okay? So that's a good thing. Now let's go to the next step. And I'm going to shut off and back on here so this video clip doesn't get too long. Okay, now next step. Again, we are going to, now we're going to tune up to 106 megahertz, you see, and we're also going to set this for 106 megahertz. So I'm going to go frequency 106 megahertz, and you can hear now. It's actually, hear that? The radio's already picking up stations. I'm in the basement on a hill, in the bottom of a hill, and I don't even have an antenna connected, and this thing is starting to pick up stations. See that? So we've already increased the sensitivity of this receiver quite a bit. So now we're going to tune the dial, and you'll watch this go as I tune up to 106. Okay, and you can see there's absolutely no static, even at negative 70 dBm. So I'm going to drop my signal just a little bit, and you can see I now have some static, and we want that. Okay, static. We're going to go back over to here, and it says now we want to adjust TC4 for maximum indication. Okay, So TC4 is this oscillator right here. And just like this one here, this one is going to adjust the upper scale. Now, if you look, here's what I'm talking about. I'm not exactly at 106 megahertz. So if I move this to 106, listen to the sound, what happens. And you can see we're off center. So what we're going to do now is, turn that down. So what we're going to do now is, I have it set where I want the dial to be. I am now going to adjust this until my signal pops in. I'm going to adjust TC4. Okay, so let me get on TC4, and I'm going to use this ceramic one for this because it's a smaller adjuster. Right like that. I'm going to move you over to here, and I'm going to turn up the volume so you can hear it a little bit, and we're going to adjust it. Now this one's really sensitive usually, so we'll see what happens. I'm barely touching this. And there it is. Okay? And very, very hard to get it dead on because this one is a lot touchier adjustment. So you have to kind of fool with it a little bit to get it to come in properly. Okay. Okay. Now, next thing we're going to do is TC1, TC2, and TC3 again. Or I'm sorry, TC1, TC2, and TC3. And, oh, guess what I did, guys? I adjusted T1, T2, and TC1, TC2. I did it backwards. My fault. I didn't even pay attention. So we're going to have to go back to our 96 again. So let's start over again. Okay guys, I'm going to leave this in here because as you can see, when I'm trying to talk and do things at the same time, it's like walking and chewing gum, you know. So please forgive me. Let's start over. We're back to step one again. We're back at 90 megahertz. Everything else the same. I have my tuning dial back down to 90 megahertz where it should be. Okay. And I am going to adjust this one that I did off camera. I'm going to adjust this T4 and bring my channel in again. So we're going to adjust this and we're going to bring our sine wave back in clear. Here we go. You ready? See that? Okay. And there you go. And just make sure it's perfect. Okay, that's pretty good. And now we're going to go T6 core again, and we're going to center it, which is right here. And I think this is the same adjuster. And I'm just going to move my tuning meter till it's centered. Okay, that's it. And you can hear much clearer. Then we're going to go back over to here again, and we're going to go a little bit, and we're going to adjust. This time we're going to adjust T1, T2, and T3, which is what we should have done. The coils are at the low end, the patters are at the high end. So that was my fault. And that's what happens when you're trying to look at two different things at the same time. Okay, so here's number one. And let me make sure I'm getting into the slug here. There we go. And let me move you over here. And we'll see if we can get any more peak out of this. Okay, that one was perfectly peaked. So now let's move over to RF coil number 2, like this, and go back. Here we go again. That one's peaked. Okay, so that one's good. Let's go to number 3. Here we go. Yep, there we go. So all 3 of those were actually good. Those ones, and those are coils, they usually don't go out. It's the patters that usually go out. So now we're back to where we were here a minute ago, and we're going to move now up to 106. So frequency, okay, here we go, frequency 106 megahertz, and we're going to tune our dial to 106. And that one again is a little stronger, so we'll go to negative 80 dBm. And again, it's just a teeny little bit off, so we're going to move it to 106 right on, and then we're going to adjust the oscillator, okay, right here. And we're going to adjust it to bring it right on. So here we go. And watch the scope. Very touchy. Right there. Okay. And pretty good. And then once again, we're going to use TC1, TC2, and TC3. And of course, since we messed with them, I would expect that they're now going to be a little bit out. So let's go ahead and touch these up. Okay, so here's number 1. Okay, that one's pretty peaked, so it was good where we left it. Here's number 2. And that one was off by a little bit. Okay. And here's number 3. And it was a little bit. Okay, that's pretty good. All right. Okay, so now that we've done it the right way, let me turn that back down. We go back to this and repeat the above adjustment for steps 5 through 11. So basically they have you go back and forth and do this a couple more times until everything is tuned right into place. And then last but not least, we're going to adjust the T5 core. Okay, T5 is your IF transformer, which is right here, your intermediate frequency. And we will do that last of all. We'll go back to 90 megahertz. Okay, frequency 90 megahertz. We will tune back down to 90 megahertz. So move this down. And okay. And I'm going to, it's off just a teeny bit, and this is what they're saying about going back and forth. So I'll go back in here, and I'll bring this back in like that. See, it was just a teeny little bit out. Right like that. So we're back on frequency. And then T5 core, put a little static in it. And we're going to go to T5 core, and you can see now radio stations are trying to come through my signal generator, you know. Hear that? So this tuner is really trying to pick up stations now, which is good. This is great. So now we're going to do T5, which is right here. And again, that is a coil. So we will need our alignment, hex alignment tool, and I will need my missing flashlight that I just set down somewhere and promptly forgot. There it is. And you go down here, and you can see this one here is actually not a hex, it's actually a little IF transformer. So we'll get down in here, and all we're going to do now is go for maximum signal. So we're just going to adjust it. And as I expected, it's peaked out as it is. So that's a good thing. And now we're going to go to, if you look here, T6, we're going to go to detune the SX1050 to noise only. So the first thing I'm going to do is go over here, and I'm going to shut RF off, and you can see the output disappears. So there's no output. I'm then going to tune this until I get pure static. Okay, that's just plain white noise. See it? No sound at all. And now they want us to adjust S6 or T6 again, which is this one we just adjusted. They want you to center the scale again, and it's, if you look right now, it is off by a fair amount. Okay, so we're going to adjust that. And let's see if I can get this back far enough that I can get it in the shot. I'm not sure. Let's see if it'll focus. Okay. So let's see if I can get both things into the... Nope, can't do it. Okay. So I'm going to adjust it. And all we're going to do is we're going to take that T6 and move it just a little until we're at center scale, and you can see we are now centered on the scale. Okay, right there. And the camera's at a little bit of an angle, so don't let that fool you. I'm looking straight on to the meter, you're looking kind of at an angle with it. So now the tuning meter is centered. The next thing they want you to do is now they want you to set this to 98 megahertz, okay? Which is exactly halfway of through your scale, right? Between 88 and 108. So we're going to go up to here. We're going to do frequency 98 megahertz, RF on, Okay, and again, and this is where they want you to actually measure the output, okay? And this is where you're setting your, if I'm not mistaken, this is where you're going to set your meter, okay? So you want less than plus or minus 10 millivolts. So in other words, you want it to be right around 0 volts. So you're going to set this to 60 dB, and I may have to do a little bit of a calculation to figure that out. I think, again, they're talking about dB microvolts, so we will have to convert 60 dB microvolts to dBm, and then we're going to adjust the upper core of T7, which is this one right here, the top core right here, and we're going to set that. Basically, we're going to null it out at 0 volts, okay? And let's see here. And let's see, they want us to connect the millivolt meter, it's very hard to see, to this pin right here, which I think is pin 8, okay? I'm pretty sure. So I do have a millivolt meter, you know, high impedance one, but I think we can actually use the fluke meter for this one, and it'll work just fine because it's got a very high input impedance. So let me get set up for that, and I'll be right back. Okay, I couldn't really take it anymore, so I sat down and figured out the dB mystery here on this, and what they're talking about is dBu, which is dB microvolt. And if you cross it over, 100 dBu is basically 1 millivolt of signal, which is a ton of signal. And the 8 to 10 dB is roughly 3 microvolts of signal. So, which is very similar to my -50, -60 dBm. The reason that I think they do this is because if you notice on their little setup, they want us to go into the 300 ohm terminals of the antenna, and they want you to use a 300 ohm dummy, and dBm is usually referenced on your you know, on your test equipment to a 50 ohm load, not a 300 ohm, which can cause confusion. So by making it volts instead of watts, that gives you you know, a constant. I guess that makes it easier for them. Again, it's, you know, most test equipment is referenced to a 50 ohm output. So mystery solved, okay? Again, it's not that important. And the right here, this part that we're going to work on, which is adjusting the lower core of T7 and the upper core of T7, really what this is all about, okay? 60 dB is, oh, let me look that up. Hold on. Okay, I stand corrected. 100 dB U is 100, look right here, 100 millivolts, okay? 60 dBu is 1 millivolt, okay? So what they're saying here is they want you to feed, you know, a 1 millivolt signal, which again is still a lot of signal. And they want you to adjust the core of T7 and the lower core of T7. Basically what this is this is setting your center frequency of your IF, your 10.7 IF, and the bottom core is just setting the distortion to minimum. So really that's all you're trying to do. And I don't know why, but when I put my meter on this test point, I just cannot get a good reading. It always reads a lot higher. So I'm just going to use a visual with the scope, and that's pretty much what I did. And if you look, if I put 1 millivolt of video, or of signal into there, so 1 millivolt, you can see you get a really solid, you can hear it, a really solid signal. And adjusting the top slug of T7, which is right here, you can see, is basically going to adjust the center frequency. And you can see if it's wrong, you see what it does, it comes off peak. So really all you're doing is you're just peaking that signal right there with your scope. Okay? And you can hear, if you do get that set right, it'll sound clear. Then you're going to go down to the bottom, okay? And you're going to adjust the lower core, which basically all you do, I'm going to move you back down here. If you look, you're just going to go through this top slug down into the bottom slug, you can see, and then we're going to adjust that for minimum distortion, which is basically just, again, as you adjust it, you can see it kind of affects the peaking a little bit and the sound a little bit as well. So it was pretty close. I mean, it was pretty much on to begin with, so it wasn't, too far out. Now, last but not least, with that input signal of 1 millivolt, the last step of just the FM tuner is to adjust VR1, which VR1 is the pot right next to T6. So that's this pot right down here. And they're going to have you set that with 100 dB, okay, which is 100 millivolts, which is an insane amount of power. All right. So you go amplitude 100 millivolts. Okay, so now we're set to our 100 millivolts, which I still think is insane, but that's what they want. And we're just going to set VR1, which is right here, until our meter is reading around 5. Okay, we want it to be 5, and it's, if you look right now, it's pretty darn close as it sits. Okay, so let me move you down, and you can see right there that it's just kind of sitting right near 5. So, and again, in my opinion, in my experience, there's an integrated circuit that takes care of this. And that IC is very, very sensitive to this adjustment. So, right there you go. I just barely touched it. And we have, right about there. That's 5. Okay, so you can see it was a teeny bit off. And there you go. Let's disconnect this now and see if I can get an antenna connected to this and see if we get any reception. Okay, if we do, we're going to end this video right here, and the last video in this series we'll get into the multiplex, because it's another whole video in and of itself. This thing's already ridiculously long, and I don't want to get it any worse than it already is. So another one where I'll put you to sleep here. So anyhow, let's get hooked up to an antenna and see if we've gotten success here with our adjustments. Okay, let's see if we have some success. We have a little antenna connected here, and let's just see what we can get down in the basement here. there's stereo. Very good. I just want you all to know that when I first tried this, I was only able to get one station. So this alignment really made a big difference, and so did the recap. Now, I haven't even messed with the stereo multiplex, but I have a feeling that it is dead on, because if you look right now, I mean, the stereo beacon is popping right on when it needs to. So let's keep going up the dial a little more.
That was given away before the game. I didn't realize exactly.
There's the ball game I have on here and the TV in the background.
Vince will have to wait because that's a strikeout at 1-2-3.
May 13th at 9 a.m. at Stage AE on the North Shore. To register or donate.
Getting stereo. You can see, even with a just a 1 on the signal meter, we're getting stereo.
Right now, from the creators of Sprint. Reticulated pottery for baking vegetables.
The Rocksteady.
Resumes. Most people don't have the right experience.
They say sometimes you.
So I think you get the point. I think we've been very successful. I can just tell you by how this thing's reacting that the multiplex is not out. Now, that doesn't mean we're not going to do a video and go through the motions. All it's going to mean is as I make the adjustments, you're going to find that it makes very little difference, because they're probably pretty close to being peaked out as they are right now. So that's it. That's in a nutshell how you do the FM. Now, again, there are different methods. You know, even using an oscilloscope with a Lissajous pattern, and, you know, setting up the S-curve and all that. There's different ways that we can do this, and different methods depending on what kind of receiver you're working on. But, you know, when we're talking about this generation of receivers, they're all pretty similar to the process that you just saw. You're going to set up your RF section first, then you're going to peak your IF section, and all the mono, you know, get the metering set, and once all that's done, then you're going to see the next step is going to be another whole procedure, which is setting up your 19 kilohertz pilot signal, and then setting up your actual FM demodulation of the stereo, or demultiplexing, I'm sorry, of the stereo signal. So I hope you guys learned something from this, and I really hope I didn't confuse you more, especially the fact that I did the patters when I should have done the coils, and we had to go back and repeat that process. Just so you understand, in these Pioneers, the coils adjust the lower, have more effect on the lower spectrum of the bands, and the patter capacitors are what you use at the higher. If you notice, these are done at 90 megahertz, and these are done at 106 megahertz. And I just wanted to make that clear at the end of this video so I didn't confuse you all. So this one's ready to go. It's all recapped. All the pots are cleaned. The bias alignment and balance alignment are done for the amplifier. this thing's just really ready to go. So we're going to do one last video after this, which will be the multiplex circuit, and I'll try to do a little explanation of multiplexing a little bit more than I did, a little more depth than I did in this one, and we'll be on to our next project. So thank you all for coming along for the journey on this one. It was a lot of fun, and I really hope I'm helping you all out, and if so, give me a big thumbs up. I can definitely use it. And hopefully we can keep this channel rolling and keep learning some more together. So have a wonderful day. Thank you all once again. I appreciate all your wonderful comments and kind words. It really means a lot. I appreciate it. I just want you all to know that. All right.